Using constraints for drawings is important for maintaining location and size of sketch features for 3D models. Create lines that have no defined length or orientation for this exercise. These lines will be used for the majority of the demonstration. We will first start off with the horizontal/vertical constraint. The horizontal/vertical constraint is used to align a point with a line or 2 points horizontally or vertically. After selecting the horizontal/vertical constraint application, click 2 points with your left mouse button for both points to automatically constrain. As you can see, both points are horizontally constrained with one another. Next is the coincident constraint. Coincident constraint is used to place a point in the path of a line. The line on the right side is fully constrained with the point, vertex of the other line. No matter where I move this line, the point will move with it. Next is the tangent constraint. The tangent constraint is used to make a line touch the edge of a curve or circle. The tangent constraint is very helpful if you want a smooth transition between a straight line and a curve. As you can see, all constraints will leave a visible symbol in the sketch for representation, editing, and deleting purposes. The equal constraint can make any sketch object identical in size. Using the sketch dimension feature, we can verify the length of each line. If you change the length of one line, the length of the other line will change as well. The perpendicular constraint forces two lines to be 90 degrees in relation to each other. This feature can be used to make square corners and can be a replacement for the horizontal/vertical constraint in some cases. Once again, we will verify the dimensions with the sketch dimension feature. The fix/unfix constraint can be used to keep a sketch feature locked in place without needing to geometrically constrain a feature. I see it as cheating. Some people might find it useful to avoid using any other constraints. As shown, the point is held in place with zero mobility. This can be changed by unfixing the point. Next, the midpoint constraint can constrain a point or object to the midpoint of an object. To use this constraint, first select the object and second select the point you want on the midpoint. Now let's verify that each side is equal, proving that the point is constrained to the midpoint. Next, the concentric constraint. This constraint is used to ensure that the center points of two curved surfaces are constrained with one another. Next is the Collinear constraint. This constraint places two lines in alignment. Next, the Symmetry constraint. Use this to constrain two objects to each other about a line of symmetry. First, select both objects. Second, select the line of symmetry as shown. Verify the distance from the line of symmetry. Next, we will go over the curvature constraint. This constraint is primarily helpful with spline-style lines that need to be flush with straight lines. Finally, the polygon constraint. This constraint is only helpful with objects with lines of equal length and equal angles, like a square or regular pentagon. Thanks for watching.